In this tutorial, we will learn how to design a vertical borehole heat exchanger. Now that we have our loads in the average block loads module and have selected a pump, we can continue with our ground heat exchanger design. If you have any questions about how to get the loads into the program or select a pump, please review the other tutorials. To open up a vertical heat exchanger design module, we can click on this button. After doing so, it is important that we link these two modules together so that they can communicate back and forth. By linking them, it enables the software to be used in a very flexible way. We can link them by hitting this link button here. When I do so, you'll notice that there's a pink light in the bottom of each module indicating that they're communicating back and forth. Now we go through these tab panels one at a time and enter our design parameters. We can begin with the Fluid tab. We can enter our entering water temperatures. Once again, these are the temperatures coming out of the ground loop and into the heat pump. These impact the pump performance as well as the length calculations. They're critical. You'll note that the temperatures here are the same as the temperatures here. When you change the temperatures in one module, they automatically update on the other module, providing for great flexibility. For example, if I change this to 95, you'll note that the temperatures changed to 95 here as well, and the pump performance has changed as well. This enables the designer to focus on the design rather than focused on making sure the pumps are updating properly. Next, we enter our flow rate. Next, we can enter the fluid that we'll be using in the ground heat exchanger. You can hit the automatic entry mode, select a fluid type, and select a freeze protection point. In the Soil tab, we can enter our ground temperature. This is the undisturbed ground temperature, as well as the thermal conductivity and thermal diffusivity of the soil. If we want, we can check the soil tables here to see what range of thermal conductivity and diffusivity values are for different soil types. Now we can put in a modeling time period. As a default, we'll put in 10 years. In the next tab, the YouTube tab, we specify all parameters related to each individual YouTube or borehole. The pipe size, the pipe type, the flow type, the spacing of the pipe in the borehole diameter, which we'll say switch to 4.75 inches, and the grout conductivity. We can also specify whether there are 2 or 4 pipes in each borehole. Next, in the Pattern tab, we specify the number of boreholes in the design. For this example, we'll start with a 15 by 25 foot grid for a total of 375 boreholes with a separation of, say, 25 feet. We'll leave fixed length mode off so we actually calculate the length. Here we can put in extra kilowatt information about circulation pumps, optional cooling towers, etc. once we have it. And here we can put information regarding the project. All this information is included on the reports. We'll go now to the Results tab and hit Calculate, and we'll see what results we get. We have 375 boreholes. Each one's 131 feet long. Now we can do some design optimization. I'm going to double click on any of these tabs up here to expand the user interface so that we can see all of the core design parameters in one screen. First, I'm going to reduce the number of boreholes. I'm going to switch to a 225 borehole grid and hit Calculate again. And now we have a length of 218 feet. What I'm going to do now is reduce it again and hit Calculate again. And now we're at 180 boreholes, length of 272 feet. What I'll do now is I'm going to lower this temperature a little bit and hit Calculate again. And now we're at about 223 feet. So if I were comfortable with this design, I could say this is my design, and I could go up here and I could print a range of reports. Or if I wanted to, I could hit this monthly data button or this hourly data button and calculate and predict how the system's going to perform monthly or hourly. This gives designers a lot of flexibility for design optimization. For the time being, though, I'm not going to do that because it takes some time. That, in a nutshell, is how to design a ground heat exchanger.